we're going to use matrices on our graphing utility to solve a system of equations. In this situation, Megan went clothes shopping and bought 2 pairs of flare jeans, 2 camis, and 4 t-shirts for $90. At the same store, Paige bought 1 pair of flare jeans and 3 t-shirts for $42.50, while Kara bought 1 pair of flare jeans, 3 camis, and 2 t-shirts for $62. We're asked to determine the price of each clothing item. To begin the problem, we need to define our variables. We have 3 variables of interest here. It's going to be the price for the flare jeans, the price for the camis, and the price for the t-shirts. So we're going to go ahead and let X equal the dollars or price for the jeans. We're going to let Y equal the price or dollars for the camis. And we're going to let Z equal the price or dollars for the t-shirt. Next, we need to write a system of equations for this situation. Since we have 3 variables, we're going to need 3 equations. We can see from the problem setup that we can get an equation for what Megan purchased, another equation for what Paige purchased, and then a third equation for what Kara purchased. Each one of those deals with a total amount of money. So we're going to make a little note here for Megan, Paige, and Kara. We know that Megan bought 2 pairs of flare jeans, so she spent $2 on flare jeans, plus she bought 2 camis, so she spent $2 on camis, plus she bought 4 t-shirts, so she spent $4 on t-shirts, for a total of $90. Paige bought 1 pair of flare jeans, so she spent X dollars on jeans, plus she bought 3 t-shirts, so that's plus $3 and for a total of $42.50. Kara bought 1 pair of flare jeans, so she spent X dollars on jeans. She bought 3 camis, so she spent $3Y on camis, and 2 t-shirts, so she spent plus $2Z on t-shirts, for a total of $62. Now that we have our system of equations, we want to go ahead and enter this into our calculator. We're going to use our augmented matrix. Remember that the augmented matrix consists of the coefficients of the variables, and we also need the right-hand side. One thing we're going to have to pay attention to is in our second equation here, there is no y term. So we need to remember to enter a coefficient of 0 for the y coefficient. If we go to our calculator, we want to go to matrix mode. That's a second function on the reciprocal key, so we press second and the X inverse key. We want to edit a matrix, so we're going to move to the right 2 times to highlight the edit screen. We're going to go ahead and use matrix A, the first matrix. So we're going to pick matrix 1. We need to give it dimensions. We're going to have 3 rows and 4 columns, because we have 1 row for each equation. We get a column for each variable, and then 1 for the constant. So we'll enter 3, enter, and 4, enter. And that sets up the matrix for us. We just need to enter in all our coefficients now. We're going to go ahead and go through each equation one at a time. So for Megan, the coefficient on X was 2. We press enter. The coefficient on Y was 2, so we press enter. The coefficient on Z was 4, and we press enter. And then the constant was 90. Next we move on to Paige. We have a coefficient of 1 for X. Remember for Y here our coefficient is 0. We need to put that in. For Z the coefficient was 3 and the constant was 42.5. And then for Kara we get 1, 3, 2, and 62. Now that we've finished entering the coefficients for our matrix, we want to exit out of the matrix mode just so we don't accidentally change anything. So we're going to quit by pressing second and the mode key. This quit is the second function. That gets us back to our home screen. Now we're going to go back to matrix mode. So we hit second and matrix, which is the reciprocal key. And we're going to move over to math. That's the second option. We would like to get our matrix into reduced row echelon form. That way we can just read off the answer. So we'll scroll down until we find RREF, that stands for reduced row echelon form. Hit enter, and now it's asking us for the matrix that we want to reduce. So we go back into matrix. The first entry here says names, so we're going to pick matrix number 1. That's the matrix we put our coefficients in. Close our parentheses and hit enter. Now we can see from our matrix that x is equal to 24.5, y is equal to 8.5, and z is equal to 6. So coming back to our system, we can see that each pair of the flare genes cost $24.50. Each cami will cost $8.50. And each t-shirt will cost $6. And so we found the price for jeans, for the camis, and for the t-shirts.